students, so good to see you all again. So today we have three kind of gene interactions. Please see your notes, all of you. I hope your books are open. We have complementary genes, supplementary genes, and polygenic inheritance. Complementary genes, supplementary genes, and polygenic inheritance. For those students who don't have time, please remember this much, that complementary genes are found in flower color of sweet pea, Lathyrus odoratus. Complementary genes are found in flower color of sweet pea, Lathyrus odoratus, and in this case you have, please remember, F2 phenotypic ratio is 9:7. F2 phenotypic ratio is 9:7. Once again, complementary genes are found in flower color of sweet pea, Lathyrus odoratus, in which F2 phenotypic ratio is 9:7. Need point of view से इतना याद रखना है, from the need point of view. Similarly, for supplementary genes are found in seed coat color in lab. Supplementary genes are found in seed coat color in lab, and F2 phenotypic ratio is 9:3:4. You may remember 9 chocolate, 3 khaki, 4 buff. Once again, seed coat color in lab shows supplementary genes. F2 phenotypic ratio is 9 chocolate 3 khaki 4 buff. And then we have polygenic or quantitative inheritance. Polygenic or quantitative inheritance in which there are gradations. तो skin color में gradations होते हैं या flower color में gradations होते हैं, and उसमें if there are two genes which are having additive effect, two pairs of genes having additive effect, example wheat kernel color, the wheat kernel color F2 phenotypic ratio is 1:4:6:4:1. Once again, in case of polygenic quantitative inheritance, if two pairs of genes produce the same color, then the F2 phenotypic ratio is 1:4:6:4:1. For example, wheat kernel color. And if there are three pairs of genes, which are called polygenes, which say produce skin color, then the ratio is, in the F2 generation, the ratio is 1:6:15:15:6:1. If there are three pairs of polygenes, for example, skin color in humans, the F2 generation ratio is 1:6:15:20:15:6:1. This is called as polygenic or quantitative inheritance. आपको नीट के लिए सप्लीमेंट्री जीन, कॉम्प्लीमेंट्री जीन और पॉलीजेनिक और क्वांटिटेटिव इनहेरिटेंस के ये पॉइंट्स मैंने बता दिए हैं। आपको समरी में ये दिया है, आप समरी पढ़िए और आपको इतना ही याद रखना है नीट एग्जाम के लिए। एंड फॉर दोज स्टूडेंट्स who so busy with studying their PCB, NCERT, they have some time. I will explain you all again, everything in detail. So, if you want to stop the video and go back to NCERT, please study. No egos, no issues there. And if you want to learn in detail, then let's start with this. सबसे पहले we will go into complementary genes. ध्यान से सुनिएगा. Flower color of sweet pea, Lathyrus odoractus, shows complementary genes. Golden birds. These are two non-allelic genes which independently show a similar effect. These are non-allelic genes. For example, capital C and capital P. Capital C is on one chromosome. Capital P is on another chromosome. Means they are not alleles. Capital C and small c are allele. Capital P and small p are allele. But capital C and small c are on homologous chromosome, they are allele. Capital P and small p are on homologous chromosome, they are allele. So they will of course produce same effect. They will of course produce same effect. Because allele में एक dominant एक recessive होता है, but they produce same effect. But in case of complementary gene, capital C and capital P, which are non-allelic genes, they are on different chromosomes. They independently produce a similar effect. They independently produce a similar effect. For example, in flower color of sweet pea, capital C produces a white color flower. Only if we have all small p. Only if all small p's are present, then capital C will produce white flower. If you remember, the non-allelic genes will produce an effect independently. So capital C alone produces white flower. उसके लिए important क्या है कि small p होना चाहिए. तो capital C will produce white color flower of sweet pea, Lathyrus odoractus. Similarly, if we have capital P and capital P is present, and golden bird, independently capital P will produce same color white. Mind one word. Capital P produces independently same color white जो capital C ने बनाया. White. Capital P ने क्या बनाया? White. Flowers colored in the sweet pea, Lathyrus odoractus. But once again, अगर capital P white बना रहा है, what should C be? C has to be small c. So only capital P and small c produce white. Only capital C and small p produce white. So once again, non-allelic genes, capital C, capital P, independently, only capital C independent, or only capital P, independent, show similar effect. Show similar effect. Why? Must. Similar effect. Coed inverse. They produce a new trait when present together in the dominant form. If they are together in the dominant form, in other words, capital C dominant and capital P dominant, capital C dominant and capital P dominant, दोनों है, कैपिटल C भी है, कैपिटल P भी है, then together they will produce a new trait. They will produce a new trait. For example, capital C and capital P together produce a purple color flower. So, what will they together produce? Purple color flower. Wonderful. So, very nice lines. Capital C alone with small p produces white flower. Capital P alone with small c produces same color, white flower. But capital C and capital P together complement each other. Capital C and capital P together complement each other, help each other, and produce a new trait, that is purple flower. Because capital C and capital P help each other, complement each other, these genes are called as complementary genes. And what is the color produced? Purple. Nice. So you have understood the principle. Now, beautiful logic. Let's see. Complementary genes were first studied by Dixon and Punnett in 1906 in case of flower color of sweet pea, Lathyrus odoratus, which we just said. And here the flower color is purple. If dominant alleles of two genes are present together, we just said it. Flower color is purple. If dominant allele, capital C and capital P are of the two genes are present together. So, what will be the genotype of purple? Genotype of purple, ये ध्यान से सुनना, capital C, capital C, capital P, capital P. We have capital C and capital P together. Then what will be the color produced? Purple. Capital C, capital C, capital C, capital C, capital P, small p. एक small p है, no problem. Capital C and capital P together will produce purple. And you have capital C, small p, capital P, capital P. एक small p है, no problem. एक capital C और एक capital P है, तो color will become purple. And we have capital C, small p, capital P, small p. एक small p भी है, एक small p भी है, no problem. कम से कम एक capital C है और एक capital P है. What will capital C and capital P do? Complement each other, and what will be the color produced? Purple. Perfect. These are purple colors. Now the color is white if double dominant condition is absent. Double dominant नहीं है, सो कैपिटल सी और कैपिटल पी साथ में नहीं है. आइदर कैपिटल पी इज अलोन, we have capital P, small c, small c, small c, small c, or capital C is alone and we have small p, small p, small p, small p. तो कौन सा कलर बनेगा? Not purple but white. So अगर डबल डोमिनेंट नहीं है, कैपिटल C कैपिटल B नहीं है, that is absent. Then what will be the color produced? White. And what will be these genotypes? These genotypes will be, focus here, capital C, small c, small p. दोनों कैपिटल C है but P दोनों small है. So only capital C is there. P दोनों small है. तो क्या बनेगा? White. Small c, capital P, capital P. Capital P is there, but C दोनों small है. तो what is it again form? White. Capital C, small p, small p. Capital C is there, but P's are both small. White. Small c, capital P, small c. Capital P is there, but C are both small. Again white. तो यहां दो small p है तो white. यहां दो small c है तो white. यहां दो small p है white. यहां दो small c है white. So what is important to remember? कि अगर एक कैपिटल है C या P लेकिन दूसरे स्मॉल है, कैपिटल C है तो PP स्मॉल है, कैपिटल P है तो CC स्मॉल है. And what will happen then? White. As a matter of fact, I would want you all to remember, I'm sorry, I want you all to remember and even write here, I just forgot to mention here, if it is small c, small p, small c, small p, then it will still become white. It will still become white. Sorry I forgot to add in the notes. Please add it in the notes. Small c, small p है, then still it will be white. क्योंकि what is important for purple? Capital C and capital P should be complementing each other. If they are not complementing each other, no capital P, no capital C, तो complementation नहीं हो रहा है. What will be the color produced? White. So small c, small p, इससे भी कौन सा कलर बनेगा? White. And now let's see. It becomes very simple now. This was one of the easiest interaction. ये interaction बहुत easy है compared to all the hi-fi interactions that we did before. So Bateson and Punnett 1906 crossed two homozygous white flower plants, capital C, small p, and small c, capital P. Now once again यहां दोनों small p है तो क्या बनेगा? White. यहां दोनों small c है तो क्या बनेगा? White. And in the F1 generation, these are parents. In the F1 generation, what was the color? Purple. What was the color? Purple. Capital C, small c, capital P, small p. Capital C and capital P दोनों है, it becomes purple. Let's see what we just said. हम लोग अभी ने जो बोला, let's see. Parent कौन है? कैपिटल C, स्मॉल p। अदर पेरेंट कौन है? स्मॉल c, कैपिटल P। तो इसमें से कौन सा गैमीट बनेगा? इसमें से गैमीट बनेगा कैपिटल P, स्मॉल p, और इसमें से गैमीट बनेगा कैपिटल C, स्मॉल p। एक ही तो टाइप का गैमीट बनेगा, कैपिटल C, स्मॉल p, यही पॉसिबल है। एंड फ्रॉम स्मॉल c, कैपिटल P, what will be produced? Small c, कैपिटल P, स्मॉल c, कैपिटल P। एक ही तो टाइप का गैमीट बनेगा, तो both the gametes are small c, कैपिटल P। If we have learned, I hope you remember, types of gametes are 2 raised to n, where n is heterozygous. So यहाँ पर C is also homozygous, P is also homozygous. So nothing is heterozygous. So कितने गैमीट बन पाएंगे? Only one type of gamete is possible. Now, interestingly, when these gametes were brought together, check it carefully. क्या आया? यहां से कौन सा आया? कैपिटल C, और यहां से क्या आया? स्मॉल c। यहां से क्या आया? स्मॉल p, और यहां से कौन आया? कैपिटल P। So we got capital C and we got capital P. And what did capital C and capital P do? Complemented each other to produce purple flower. So parent was what? Small p, white. Other parent was small c, white. But what did from both parents F1 generation become? Capital C from here and capital P from here. Capital C, capital P complemented each other to become purple. So this became purple. And then what do you do next? We know, of course, purple flower of the F1 generation is then allowed to self-breed. Purple color flower of the F1 generation is allowed to self-breed. So we have done it multiple times. Mendel's Dahn-Hagrade ratio. So we know it logically. अभी तो कितनी बार रिवाइज कर लिया है. Which will be the types of gametes produced? Capital C, capital P, capital C, small c, capital P, and small c, small p. ये बन गए मेल, ये बन गए फीमेल. Of course, you know this now, done it time and again. And let's see what did they form. Here you have capital C, and capital P and capital P, all capital, like parent. So of course, capital C, capital P complement each other, become purple. So just one example. Very quickly now, please open your flowchart. File को open रखो, PDF file और notes print out को open रखो, and just see it. Pause the video along with it to observe carefully. Capital C, capital P, purple. 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 Wonderful. Capital C, capital P complemented each other. What was the color produced? Purple. Let's see how many purple we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 white. Let's see why. I'm using a different color. Capital C, but both are small p. White. Capital C, but both are small p. White. Capital P, but both are small p. White. Capital P, but both are small p. White. Capital C, but both are small p. White. Capital P, but both are small p. White. यहाँ तो small c, small p, small p. Absolutely no complementation white. How many whites we got? We got 1, 2, 3, 4, 5, 6, and 7 white. So we got 1, 2, 3, 4, 5, 6, 7 white. So what is the F2 phenotypic ratio? F2 phenotypic ratio 9 purple 7 white. F2 phenotypic ratio 9 7 purple white. We have perfectly understood complementary genes are found in flower color of sweet pea, Lathyrus odoractis, in which the F2 generation phenotypic ratio is 9 purple, 7 white. Brilliant. I'm sure you all have understood. And just a little understanding, थोड़ा एक लॉजिकल समझने के लिए ये क्यों होता है? Why does it happen? The purple color formation is a two-step reaction where the two genes cooperate. Capital C and capital P, both genes cooperate with each other, complement each other. That's the name complementary gene. What do you mean by it? Flower color is by a pigment called as anthocyanins. You have learned it before. Flower color is by a pigment called as anthocyanins. Now, flower में एक raw material होता है. फ्लावर में एक रॉ मटेरियल ए होता है और एक प्रोटीन होता है. नाउ जीन कैपिटल सी produces by transcription translation an enzyme which converts raw material into chromogen. Raw material, the protein, into chromogen. But chromogen alone cannot produce purple flower. So capital chromogen alone cannot produce purple flower. So if we have only capital C, क्या बनेगा? Chromogen. और purple flower नहीं बन पाएगा. Purple flower किससे बनता है? Anthocyanin से. So if the flower is only capital C, chromogen बनेगा, but anthocyanin नहीं बनेगा. So why? हाँ. Capital P, not an enter, capital P undergoes transcription translation to produce an enzyme called as oxidase. And oxidase enzyme acts on chromogen and converts chromogen into anthocyanin. So capital P produces oxidase enzyme which acts on chromogen and converts it into anthocyanin, which will now give a purple color. What would have happened if we had only capital P? तो कैपिटल C नहीं होता था, तो क्रोमोजेन नहीं बनता था. And capital P cannot act on raw material. It can only act on chromogen. तो only capital P होगा, तो chromogen नहीं बनेगा, and that means what will not be formed? Anthocyanin. तो only capital P से कौन सा कलर बनेगा? White. So last line, capital C and capital P have complemented each other to produce purple color. How? Capital C has acted on raw material and has produced an enzyme which converts raw material A into chromogen, and capital P produces oxidase enzyme which acts on chromogen and converts it into anthocyanin, which produces the purple flowers. So capital C and capital P have complemented each other to produce purple anthocyanin and are likely called as complementary genes. Beautiful. Still, this was easy, very easy compared to all the heavy gene interactions we have done. But ये भी बहुत important है, नीट में बहुत बार पूछा है complementary gene. तो please remember, dominant epistasis, recessive epistasis, ये बहुत बार पूछा है, and complementary gene बहुत बार पूछा है. तो complementary gene प्लीज इजी है, लेकिन याद रखना ये बहुत बार पूछा है. चलो, we'll have a break.